Altium Designer displays your board in its full three-dimensional glory by calculating the board thickness from the layer stackup and the component shapes from the 3D body information included in the footprints. For the components, there are two approaches to representing their three-dimensional shape. You can import a step model for the component, which you can source from a growing number of component manufacturers or from shared online resources, such as the 3D Content Central website. Alternatively, you can build up the shape from Altium Designer's 3D body objects. Importing a step model for a component is the same as importing a free mechanical object, such as a case. You do it by placing a 3D body object and then importing the step model into that. Since I'm importing the step model into the component footprint in the library, I don't get the option to link. I have to embed it, which I prefer for the component shapes. I'll place it to the side of the footprint and cancel out of the 3D body dialog. OK, I'll press the 3 shortcut to switch to 3D mode. You can see that the step model has a different orientation to the footprint. I can change that using shortcuts, or I can use the PCB library inspector. Before I reorient the model, I need to double-click to edit it, and add a snap point at the step model origin. I do that because the mechanical designer will generally design the model around the manufacturer's origin, as shown in the datasheet, which is also how the footprint has also been designed. Now that the 3D body object containing the step model is selected, its properties are displayed in the inspector panel. I can quickly experiment with the rotation values to orient the model in the right direction. To reposition it on the footprint, I press the M shortcuts, and then click near the snap point I added to grab it. Then press the J/R shortcuts to jump to the footprint's reference point, and press Enter to place it. As well as using the inspector panel to adjust the model orientation, there are a number of useful commands for manipulating models here in the Tools menu. Press F1 over a command for more information. The alternative to importing a step model is to build up the component shape using 3D body objects. Here's an LED built from 3D body objects, including 4 extruded shapes for the pins, a cylinder for the body, and a sphere for the top of the lead. Keep in mind, the model does not have to be an exact replica of the physical component. I just focus on the crucial dimensions that are important for interference checking in the design. Because Altium Designer is a true three-dimensional board design environment, you can perform clearance checking in the X, Y, and Z planes. That means you can design with complete confidence within a complex case such as this one. The board shape in the design was derived from a step model imported from an MCAD tool, which included the board shape and the case. When I initially imported the step model, I hid the case from view and from DRC. I'll display it and enable the DRC now. OK, I can see that I have a clearance problem between the case and the loaded board. The USB connector is colliding with the case. This looks like I've used the wrong step model for the chosen connector. Since I'm unable to find a suitable step model for this style of USB connector, I can create a suitable shape from 3D body objects myself. I've created that in a copy of the footprint, so I'll rename them and then update the board with the new shape. Interference checking is controlled by the component clearance design rule. To show you how it works, I'll increase the required clearance. You can see that the USB connector now fails this new clearance. Note how the actual clearance distance is detailed. That's because I enabled the Show Distances option back in the Rules dialog. You can see the real power of the 3D design mode if I zoom in to show inside the case. Here you can see one of the locating lugs inside the case and how it fits neatly within the slot in the board edge. And here you can see the board mounting peg correctly protruding through the board. If I drop down through the board, you can see the lower part of that mounting peg, which is correctly positioned to support the lower surface of the board. This level of three-dimensional interference checking is essential during the development of a complex-shaped modern product. By having it available during PCB design means you can dramatically simplify and accelerate what has traditionally been a painful and cumbersome ECAD to MCAD integration process. Once the board design is complete, you'll want the electronics designer to export the loaded board from Altium Designer so you can import it into SolidWorks. I'll delete the case before I export from Altium Designer. That way I can double check the fit of the board by positioning it inside the original case design in SolidWorks. The origin of the exported step file will be the current Altium Designer relative origin, which can be redefined using the set command in the origin submenu, and then clicking to define the new origin location. I'm going to set my board origin to the same origin used in SolidWorks to make it easy to locate the board in the case. The measurement units will be the current Altium Designer units, as displayed on the bottom left of the status bar. Press Q to toggle the units between metric and imperial. Something to be aware of: the step file format is not compact. You can create very large files, even from a small board design. To help with this, you have the option to export only selected components, or pads. If I only wanted to export specific components, such as the connectors and tall components, I would create a component class of just those components, and then select the component class before exporting the board. For this small board, I'll export all the components, and select these two mounting holes to be included. To export the board from Altium Designer, I select the Save Copy As command, and set the type to Step. In the Export Options dialog, I'll include the components whose shape has been created from 3D bodies, and also those components that are using imported step models. I only want those two mounting holes in the step file, so I'll leave the pad option set to Export Selected. Here's the bottom half of the case in SolidWorks, ready to check the fit of the board. First, I'll open the board's step file from Altium Designer. Once that is opened, I can switch back to the case and insert the board. Because the SolidWorks case and the Altium Designer board have the same origin, I can just click OK to position the board in the case. The fit of the board looks good. The ability to perform true three-dimensional printed circuit board design is unique to Altium Designer. Much more than a simple visualization tool, it gives you an unprecedented level of design confidence, particularly if your product has a complex case design. And by using the ubiquitous step file for transfer, you get tight integration with SolidWorks. You will need a graphics card that supports DirectX 9 and Shader Model 3 to operate Altium Designer's PCB editor in 3D mode, but these are readily available, and there's a growing pool of graphics card performance data available on the Altium website. Regardless of the task, Altium's unique 3D board design environment delivers the industry's most comprehensive ECAD to MCAD design solution.